Someone you may not know if you're new, but if you've been around a while, you know Andy. Andrew Gluesenkamp is joining us tonight. He attended the University of California at Davis, where he graduated with a BS in zoology in 1993. He entered the graduate program in zoology at the University of Texas in 1994 and graduated with his PhD in zoology in 2001. He has conducted postdoctoral research as a Parsons Fellow at the Los Angeles County Museum of Natural History before returning to us in Texas to work as a karst specialist and a cave biologist. He worked as a biological consultant specializing in karst issues, a university lecturer, and a skeletal preparer for the Texas Memorial Museum, in addition to conducting research in California, Texas, Cuba, and Mexico before becoming the state herpetologist for the Texas Parks and Wildlife Department, a position he held for 7 years. He is currently the director of San Antonio Zoo's Center for Conservation and Research, where his work focuses on cave organisms, fish, amphibians, and reptiles. Please.
What's it do? I just want to say hi. There's so many new faces in this room who I've never met before. That's super exciting to see the grotto growing. And also, I apologize for not being here more, but I'm busy a lot. I also am not an NSS fellow. So many of you are familiar with the Texas Tetra, also known as the Mexican cavefish. Some people in this room may have been involved in some of the early research, discovering new populations and doing biology on this species in Mexico. You can see, there's two sort of extreme morphotypes. I'm going to use a bunch of long words, and this is a talk where I don't mind if you just stop me and say, what the hell are you talking about? That's fine, but two different morphotypes. There's a surface form, which has abundant pigment, well-developed eyes. They've got kind of muscular little bodies. They live on the surface. They have to deal with surface things. And then there's the super awesome cave form. They're blind, they're depigmented. You can see this animal's fat. I'll go into some of those differences later, but these extremes are really, really obvious. And what's cool is that this cave form, these surface fish have colonized cave habitats in Mexico about 29 separate times. So there are 29 separate cases where this cave morphology has arisen in Mexico. It's a really important system for evolutionary research and also biomedical studies. So they've been around a long time, 20,000 or 30,000 years, depending on which invasion of the Mexican cave habitats you're talking about. But that's pretty old for us. That's pretty rapid for the evolution of such an extreme phenotype like that. And I said that's really important for various research studies. I just did a Google Scholar search on the term and came up with 21,000 records. So that's a lot for a little fish. And all kinds of research. So there's a meeting in Mexico every 2 years with people from all over the world, and they talk about things like morphological evolution, genetics, behavior, physiology, development. This is a classic model for studying the degeneration of eyes and for vertebrate adaptation to the cave environment. And so the really neat things have been done with it. They've been used for studying neural development, but also autism. So basically, if you compare all the behavioral traits that the cavefish have to the behavioral traits of their surface relatives, the cavefish are on the spectrum. They're autistic, which is really interesting to have a natural model to compare issues with humans. And same thing, they're currently being widely used to study sleep cycles because cavefish don't sleep. Surface fish sleep, the cave relatives do. Most organisms, if they don't sleep, they're going to die. Somehow the cavefish are able to cope with that. In addition, my collaborator on the project I'm going to talk to you about, she studied diabetes in these fish. So as many of you know, cave organisms, they have to survive a really extreme environment in terms of there's very low energy, not a lot of food available most of the time, and it might be a really long time between meals. And so these organisms need to be able to take mad advantage when there's food available and then survive through however long a period until food pops up again. So some of the other cavefish like Peter and I work with, Mexican blind cats, they've been documented in captivity, withheld from food for up to 44 months, and they get skinny, but they don't die. When you feed them again, they plump back up. So can you imagine going almost I can't go 4 hours, but going almost 4 years without a meal? And in fact, some of the wild cave blind cats that have been collected were much, much skinnier than the fish at the end of the 44-month study. So they might have been without food for like, I don't know, 6 years, or since some of you were born. And so a little bit about Astyanax in Texas. It's native to the Rio Grande and Nueces drainages. And it's widely thought that the northern limit of its range is determined by cold winter temperatures. I know it's hard to imagine right now, but it gets too cold here in winter too often for these guys to be happy. And so they're abundant in parts of the state, the southern part of the state in West Texas, where we have these warmer winter temperatures. However, if you've ever been snorkeling in the San Marcos or the Camal or Barton Springs or any one of these spring-fed rivers, you've seen Texas Tetra, Mexican tetras here. They're really, really abundant. So they love our spring-fed rivers for an obvious reason, right? That spring water coming out of the ground is a constant temperature. Those rivers are warmer. That's why we actually swim in places like Barton Springs in winter. And they become really abundant as a result of humans bringing them in. So since the early 1900s, they've been introduced into central Texas for various reasons. I'll go into some of that in a minute. And they've been established and they've persisted in a lot of these places. So what's fascinating to me about them, so Kara mentioned that I do work on cave biology, and I've been trapping in wells and caves for a long time. And it's not all that uncommon for me to pull up a salamander trap out of a well or a cave, and there'll be an Astyanax in it, one of these fish, or I'll catch them in a cave way upstream from the entrance. So I've been collecting them for years and started sort of rolling around in my head this idea about, what might be going on with these fish, because I know they have this propensity to invade the cave environment in Mexico. What about these new arrivals that we have here in Texas? And so this is, actually, I just want to stop for a second. I want to give you all a piece of advice. Always talk to the person sitting next to you. If you're on an airplane, talk to them. If you're in a taxi, you know what I'm saying. If you're in a taxi, talk to them. Sometimes it doesn't work out, and I've had some bad experiences, but I've also gotten free round-trip tickets to Ecuador that way. And I also started this project with my collaborator, who's one of the smartest people I ever met, by talking to the person sitting in a taxi. So just word to the wise. Oops, sorry. How do I go backwards?
It's either above or below the arrow that's marked. There you go.
Yeah, perfect. Okay, so this is a map representing, in gray, you can see the historic range, was considered the natural range of the species in northern Mexico and Texas. And then all these blue dots are observations of the species, and the size of the dot has to do with basically how many records there are. So you can see that it's really well documented throughout Mexico and along the Rio Grande. And holy heck, we've got them all up here in central Texas, and then even things all the way up to Red River, like Lake Texoma. In fact, there was a breeding population in Lake Texoma for many years that probably was introduced when they started the striped bass population, and they all froze out. But they haven't always been there. So I don't know how to click the thing. Can you click a thing to make a thing? Do a thing? There's usually a thing that you can click. like a thing bar.
It's in the upper left hand of the map.
No, it's usually at the bottom. Although, something if you can't see it. Yeah, here we go. So this is a timeline from 1843 to 2008. Our friends at Fishes of Texas put this together for me. So right now we're up to about the turn of the century, just about there. Boom, there you go, San Antonio. Oh, they're going to spread all over now. And we're about up to now. So I know that went really fast, but I talk a lot, so I really want to keep it quick. You can see that it's pretty clear that this was a South Texas species that in later years, sort of mid-century, we had a couple of blips. You saw that one pop up in San Antonio, but really it wasn't until about mid-century that you saw this where they took off all over, right? And it's still happening today. So I just want to point out that central Texas and the northern parts of their range, those aren't exactly far off, poorly studied areas, right? This is just a photo I took of the grabbed somewhere of the Guadalupe River. Like, people know about the Guadalupe River. If there was a fish in that river, somebody would have found it before 1953 when our friend Jeff Hosey's dad documented, Dick Hosey documented the first occurrence of Astyanax in the Guadalupe River in New Braunfels in 1953.
Wow.
I guarantee if it was there before 1953, someone like Dr. Hosey or Dr. Hubbs would have found it first. So we have some of the preeminent Texas fish biologists in our area during that time, and they didn't record them anywhere until the mid-50s. This one I love because this earliest record that I could find, and what's so cool is I actually found documentation of it. This guy named R.L. Shiner explained to Brown back in 1953 that his dad had gone down to the Rio Grande and scooped up a bunch of these Mexican tetras and dumped them in San Pedro Spring. For what reason, I don't know. Probably because they're pretty, maybe for bait. And what's cool about that is that in 1908, the year that he introduced the fish, they also popped up in the San Antonio River at the zoo where I work, and that's one of my study sites now. And that was when the very first record says San Antonio River occurred. So probably the occurrence of that fish in the San Antonio River was due to that man bringing them up there and dumping them loose. And then I've actually had other firsthand accounts from individuals who stocked them in other rivers, like up in Salado Creek. I met the guy who introduced the fish there. And he said, yeah, it was kind of this thing we all did. It was like llama farming. You go down and seine up all these fish out of the river and bring them up here and sell them as fish bait. And a lot of guys were doing it in the 50s, early 60s. And if you remember that map, that's when they popped up. So that's kind of cool. Also, in that same paper, Brown explained that tetras were introduced at the headwaters of the San Marcos River between 28 and 31 because the guy who ran the federal fish hatchery there introduced not only tetras but Rio Grande cichlids, which that's a whole nother story I'll tell you some other time. But both of these non-native fish were introduced by the guy that ran the federal fish facility there. So getting back to what I think is cool, is that it's been documented in a bunch of caves and even wells here in Texas. So Johnson's Well, Rattlesnake Caves, and these are both in San Marcos. Spring Creek Cave, which is right next to Cave Without a Name, Valdina Farm Sinkhole, right, Seco Creek, Phantom Cave, way out West Texas. That's actually the native range of the species, so that's kind of cool. And then Honey Creek Cave, which is going to be the subject of this talk tonight. It also occurs in some ephemeral springs, such as Blue Hole. And believe it or not, back when they introduced the tetras to San Pedro Springs in 1908, it was perpetual. It's been ephemeral basically ever since. And it's actually went for about 70 years of being mostly dry. It's been much, much better, and we've had much longer periods where it actually flows, thanks to water conservation by entities like the Edwards Aquifer Authority. So actually Blue Hole and San Pedro Springs are also study sites for me, which is great because they're like 2 miles from work. I want to give you an example. When I say ephemeral, most of you who have ever been to Blue Hole is there behind gosh, what's the university? Thank you. I mean, I drive by it every day. University of the Incarnate Word. You look down, there's a bunch of sunglasses and Dixie cups and stuff. But it's been boiling like this since October. It's epic. And it's hard to make it out, but there's a whole bunch of tetras in this column of water. And in fact, the fish showed up just as soon as it started flowing. So it's possible that those fish swam up the spring run from the river, but it's also possible that those fish were hanging out underground until the water came up, just like our salamanders do. Yeah, man?
Do any of those show cave adaptations that they came out of there?
I don't know. Let's see what my talk says. That's a good question. I did not pay him to ask that question. By the way, that blue hole looks fully diveable, and I know someone who went in it. So
You did that or no?
I've got access. We should check.
We should.
Excuse me. So Astyanax is found in Honey Creek Cave. Y'all know as long as cave will stay, go and write your representatives and tell them not to let them dump sewage water into the creek. Type locality for one of my other favorite cave critters. And what's cool is that the downstream portion of the cave has a nice bat colony. There's a lot of energy in the cave at that stretch. And so it's a nice place to be a fish if you're going to be a fish in a cave. And here's a map that Kurt Menking provided showing basically our study area in the cave. So it's no accident that for almost 20 years I've found research project after research project that require me to spend long hours and many trips in this part of the cave. If you haven't been to Honey Creek Cave, don't get talked into doing one of these tank hauls or something. I've never been upstream of the cave or shaft. Yeah, why? Oh my God. This is a really gorgeous part of Texas, and you know, for passport reasons, you can't go to Mexico. You could convince yourself you're in a Mexican cave at that little stretch. Anyways, love that place. And Honey Creek doesn't suck either. So most of us know that the spring basically starts where the cave stream flows out, right? The resurgence of Honey Creek Cave is the living headwaters of Honey Creek. And Honey Creek flows for about a mile and a half or so until it hits the Guadalupe River. So that's not very far for a fish to swim from where Astyanax were first discovered in the Guadalupe River back in 1953. And sure enough, there's Astyanax here in the Honey Creek. These are some of our cool fish traps that we use to collect them. And they've been documented in the cave. I've seen them for years. I sent out a poll, some of you may remember, either on Cave Text or Facebook a few years ago, asking what's the earliest date that you have where you remember seeing Astyanax in Honey Creek Cave? And Alan Cobb and Linda Pallett said, well, 1980s. We saw them in the 80s. I asked James Riddell, he's like, I don't remember seeing them there. So thing is, technology changes. I mean, back when Riddell was going, they may not have been using masks. They're definitely wearing blue jeans instead of wetsuits. So the fish could have been there much earlier. Yeah.
What are you using as your fish trap there?
I call these umbrella traps. I don't know. They sell them on, you can find them on eBay or Amazon or whatever.
Fish traps?
Yeah, they're fish. They call them like fish and crab or whatever. They're super delicate. It's basically a mesh umbrella with a bottom. And so you pop it out, and it's got these little funnels, these little invaginations around the side, and they're awesome. And you can pack like 20 of them in a cave pack. So I really like them, but they're not very robust. Like you'll really shred them in the wrong places. Oops, sorry. I gave up my whole talk. There we go. Okay. So, I have the best looking field assistants.
You might be ignoring.
I'm sorry?
That's okay. So, I don't know, maybe you're planning on showing a picture of the cave entrance to the creek itself.
No, my
there's a
camera
series-
it always has water on it when I try to take that. We
Okay.
had some photos.
Well, there's a series of waterfalls, so I'm wondering if you're saying that they started in the creek do they jump up the series of waterfalls to
Well,
get to the cave?
that's a
or-
great question, and that actually relates to my current concerns about what's going on with the proposed sewage plant. Thanks for tying that together.
Sure.
So it's true. The cave is maybe the research is about 3 meters of steep riffles above the creek. And these fish can jump, but they're not like salmon. They don't want to jump up a big waterfall. But we find Astyanax, green sunfish, blunt-nosed minnows, yellow catfish or yellow bullhead catfish. We find a bunch of surface fish in the lower part of the cave. There's really only one way that those fish get in there, and that's if you look up in the cypress trees along the creek and you see all the flood debris that's 30 feet overhead. That creek floods violently and not infrequently. When it floods, it really floods, and most certainly those fish are being washed into the cave during flood events. What's important about that in terms of this wastewater treatment plant they want to put in is that means that it's a localized flood event, right? Because if it was regional and the whole catchment area for this cave was getting rained on, the cave would be blasting a freight train of water out of it, and you wouldn't have these little surface fish getting up in it. So it's this sort of biological evidence that we have extreme localized flood events at the headwaters of Honey Creek when the cave itself is not flooding. And we know that because these fish that aren't good at jumping like sunfish wind up in there. But it just so happens to be exactly the same circumstances under which any water treatment plant will fail, right? When you get these extremely heavy localized rainfalls, they can't keep up with it. They gotta dump untreated waste. Under those circumstances, where's that waste gonna go? It's gonna go in the cave. So get your through trips in now. So we set about, so now I've set the stage. We got fish in the cave, we got fish in the creek, we got lots of fish in other creeks. Let's see if there's anything going on. So my wife and my collaborator, Suzanne McGaw at the University of Minnesota, and my kids, here's Jack, he just turned 13 on Sunday, and several other people in this room, raise your hand if you've helped, yes. Have helped with collecting in the creek and the cave, and it's been a lot of fun. It's a great excuse to get out there. By the way, the creek is all in the state natural area, so they only allow guided tours on Saturdays unless we're going there to collect fish, and then it's really bitchy. And so I threw this one in. I wanted to show these are all fish collected on the surface, and they're not alone there, right? So I didn't get any big fish in my traps. I didn't get any of the gar or the largemouth bass or the large sunfish are super abundant in that creek. But you can see that, like, here's a green sunfish, here's a whole bunch of crayfish, and here's these Astyanax. And so when you think about, I talked about the cave being this extreme environment, and the fish are adapted to going through long periods of starvation, yada, yada, yada. The freaking surface is an extreme environment, right? We already talked about how their northern range is limited by winter cold. Well, that doesn't happen in caves, but these little surface fish got to deal with that. They're basically the top predator in the cave. On the surface, they're top appetizer, I would say. So they've got a lot to contend with on it. And so, you know, it's true of all the other systems I've studied with salamanders and stuff. We see these sort of extreme forms in caves, but they're only extreme in comparison to the surface worms because the selective environments are radically different, right? And so there's Matt's question. So do individuals from cave and spring populations differ from their surface relatives? And so why were we collecting all these fish? Well, we collected a whole ton of these fish, sent them up to Minnesota, where Suzanne set them up in her laboratory, put a whole army of postdocs, graduate students, and undergrads, basically in dark rooms for weeks and weeks and weeks, and did a bunch of studies. And so one of the first things I'm going to show you is just basic morphology. If you compare, so here's the cave is in pink, and surface is in blue-green. If you look at the length of the fish versus the number of fish that have it, you can basically see that cave fish are shorter than surface fish. Right? Surface fish tend to be longer than cave fish. That's cool. That's actually a significant difference between those two. And these are fish where you could throw a fish from one to the other. You could throw a fish from the creek to the cave or vice versa, but the fish themselves don't seem to be doing that. We also see when we measure their eye, that the cavefish, interestingly, have relatively larger eyes, but I'll explain that a little bit later. And that they have slightly more dorsal fin, or more posteriorly set fins. So their dorsal fin is a little bit further back. And why the hell would we measure that? And why do I think that's a significant difference? Well, when I said these little surface fish live in an extreme environment, they live in areas with high flow. They got to be all escape predators. They got these muscular little bodies where they got to get away and do stuff. And so they're fit. And the cavefish, if you remember the first slide of this presentation, they're fat. I mean, they're basically floating sausages. They don't have, they don't have to work. They don't have to work too much. And so that dorsal fin placement is actually related to the lifestyle that the fish are required to have, right? And this eye size thing, as you can imagine, cavefish typically would have smaller eyes than surface fish. And there are a couple of things going on here. One is that the cavefish are actually in slightly poorer body condition, so their eyes look bigger because the rest of them's kind of scrawnier in this system. But also there's another thing going on, which is twilight zone. Okay, color measurements. So we wanted to look at like, well, you know, do they look different? One of the premises I started with is the cavefish just look different to me than the surface fish. Maybe they're more pale. And so Suzanne, being a brainiac, came up with a really great way to systematically compare the color between cave and surface fish. I'm using these three metrics, so hue, saturation, and lightness, brightness. Now, so far in our study, the only one that came out is significantly different between the two was saturation. And saturation is basically, the more saturated a color is, the less gray or black it has obscuring it. So you might think, okay, well that's reduced pigment, that's reduced melanin that's allowing those other pigments to shine through better. We didn't actually measure melanin, so I'm not saying that, but I think it's melanin. And here's a great example. You know, this is a Honey Creek cavefish. Here's a Honey Creek surface fish. Obviously, we pick kind of extreme individuals, but you know that's about the difference, right? And remember, more than likely, the fish have only been in the cave for 75 years. So that's pretty extreme for that length of time. This is a result that I absolutely love. So cavefish have about 3 times more neuromass cells than surface fish. So neuromass cells are these little cells, this little jelly ball with a hair sticking out of it. That's how they detect water movement. And that's really important if you can't see, right? So they're feeling their way around, feeling prey, etc. Mexican cavefish have many times more neuromass cells than their surface relatives. And these fish, like I said, they've only been here for 75 years, but they got 3-fold increase in the number of these sort of specialized sensory organs that the surface fish do. That's cool. Come on, it's cool.
Cool.
Yeah.
Probably cool.
Significant difference under different conditions in the amount of worms that they ate, right? So we'd feed them sort of a known quantity of worms, and what my friends, and it was significantly different between cave and surface fish. Now, if you think where I said these, the cave fish in Mexico, they're these fat blobs, and they've got all these tricks to survive long periods without starving, and they have all these cool tricks that they basically don't develop diabetes despite their funky diet and all that. You could think of that as being sort of a metabolic shift in these fish, that they don't require to eat as much as the surface fish. And here's another one that I absolutely love. So if you put the fish in a bucket and basically stick a video camera over them and you just record it for 10 minutes, and then you create a heat map of where that fish was over that period of time, you can see that cavefish like to hang out around the edges of the bucket. Surface fish like to hang out around the center. And this is super consistent, like with 20 individuals of each form, you can see this pattern really clearly. And so that makes tons of sense, right? Surface fish are avoiding big, large, shadowy, dark things that could be a hiding place for a bass or a gar. They're not going to be close to the bank if they don't have to be. They're sort of a mid-water fish. Cavefish all the food, all the action is on the walls and the floor of their environment. So they're looking for food and hang out around the edges, and they got nothing to fear. And the surface fish are hiding in the center because they got a lot to be afraid of. And here's a graph showing that that's actually statistically significant. This is a really cool one. This is called the vibration attraction behavior. And this, the standardized method for doing this is with an Oral-B electric toothbrush, because it happens to, and you put a little a pipette tip on the end of it, and it vibrates at about the same frequency as a cricket swimming. And this is actually like a standardized thing in the literature. But so there's this big difference between Mexican cavefish, Mexican surface fish, and whether or not they're attracted to a vibrating rod in their environment. And you can see here that, oh, by the way, the cavefish are much more attracted to a vibrating rod, right? Vibrations mean a lot if you can't see. And you can see here that our cavefish are much more attracted to the vibrating rod. Well, actually, it says not statistically significant. We've run some more tests, it is. So they're more attracted to that too. Okay, so a little table summarizing. Mexican cavefish versus their surface counterparts, Texas cavefish versus surface. Now these are all Honey Creek, right? Honey Creek cave, Honey Creek surface. And all the ones that I have listed here in black, the Texas fish follow the same pattern as the Mexican cavefish. Those in black, or in red, I'm sorry, they have the opposite pattern. So for example, the mass for unit length is reversed in these two. Eye size is different. And so coming back to eye size, it looks like the fish in Honey Creek Cave are actually a sort of poor body condition than the surface fish, so not quite that metabolic thing that I was talking about. And I took some steps to actually measure this by sending specimens out to have them serial sectioned and have the intramuscular fat measured, and the post office lost my package. Yeah. So anyways, it could be either way. But there's another reason why you might expect eye size to be larger in these fish. If you remember the map that I showed you, they're in the lower 100 meters of the cave, and they're actually, it's dark to us, but there are 2 entrances to that cave, and there actually is some light. Maybe not enough light for these fish, but maybe there is. And the vast majority of the individuals that we've collected are in parts of the cave where there is humanly perceptible light. And so if you think about an organism that is being adapted to the twilight zone, they're going to have all the same behavioral, physiological, and morphological shifts as a deep cave organism would, with one exception, which is they're going to have bigger eyes so that they can see prey as well. Are you raising your hand? Sorry.
Yeah, I was curious about their mouths. Are they're like terminal? Are they changing because of what they're feeding on? Because they're in a different location?
We haven't documented any differences like that, although we are in the process of studying the taste buds. So it differs dramatically between cavefish and surface fish. Cavefish have way more taste buds. Once again, they don't have sight and they taste the environment. So we're actually measuring that now. But in all these other ones, in feeding, so yeah, I've got feeding in red, but that's because in some Mexican caves, the fish eat less than the surface, and some they eat more. So where there are 29 examples of Mexico, there happen to be some that differ from others, and so I put that in red because, you know, I don't know, could be a cave thing, might not. And the aggression thing is actually really interesting here too, is that we found that, so I said that cavefish are typically on the spectrum in terms of, on the autism spectrum. They basically lack social behavior, which includes aggression. But our cavefish tend to be more aggressive, and that's actually something that you would expect to see in populations where the animals are stressed for resources. So this and this and this are probably all related in that the fish aren't finding as much food as they need. They're skinny, so they've got lower mass for their length. They've got bigger eyes for their length, and they're pissy because they're hungry. So some of the things we're doing now, we're looking at taste buds, teeth. These are all characters that have been well documented. They're significantly different between cave and surface fish. Stress, and then really important. So I've said, well, they're different, they're different, they're different. But maybe that's just because they were raised in a cave. is this a genetic difference? Are we gonna see this when we breed these organisms and rear their offspring in the exact same lab environment? That's what we're doing right now. So once we have captive-born individuals, then we can compare all these things. We can do other experiments are called quantitative trait loci tests, and basically get down to answering the questions of whether there's a heritable genetic component to these differences. So I haven't called it, they're not evolving in this talk, they're just different. And then, of course, expanding this, it'd be great to be able to document that this is a trend that we see in other populations. So, brief wrap up, we brought them here. The ones in Honey Creek Cave differ from the ones in Honey Creek in a whole bunch of traits that are similar to the differences between 30,000-year-old cavefish and their surface relatives. And that some of these also they differ from their surface counterparts in a way that's not like the Mexican cavefish, and that may be that third axis that they're basically adapted to a twilight zone, which nobody else has actually ever studied. Researchers will say these fish study in the dark or light and not in that twilight zone, which is so important. So,
what does VAB stand for again?
Vibration attractive behavior, the Oral-B toothbrush study. Yeah. And so I actually had a really lively discussion with like the world's experts on this fish. But I gave a similar talk earlier this spring, and I said, you know, y'all have ignored like the third major environment these fish live in, which is a twilight zone, and the room was just silent because I kind of forgot about the twilight zone, which would, like I said, it would explain so many of the differences that you see in the patterns that you see in the fish are adapted to the twilight zone, have all the same selective pressures as fish in the cave zone with only one difference, which is the eyes. So you only need mutation in sort of one sensory system, and you got a fish that can do great in a cave. And so instead of having to connect dots that are this far apart between how the surface fish become this blind cave fish, it's like there's a twilight zone, and they went dink, 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 dink. So yeah, we'll have a good talk next year. And I just want to point out how excited I am about this, because this is a really well-studied system, 20 or 30,000 years, but those Mexican cavefish systems, you could never reveal sort of what were the first steps, how did they get there, because it happened so long ago. But here in this system, we're looking at the first 100 pages of that story. So we got the first 100 years, or maybe even 75 years, of the steps that a species takes to evolve to the cave environment, which is really cool, and it wouldn't be possible in their native range, right? It's only possible because they're introduced.
How many generations is that?
They breed every year, and so we're thinking that's probably about 60 to 75 generations for the Honey Creek guys. So not forever. I mean, they maybe live 2.5 or 3 years in the wild tops. And I just want to brag, because we just found out this week, but our first paper on this system has been accepted for publication. It should be out in a couple of months. And when it's available online, I'll post a link where it's available to y'all. It's better than Soma or Trazodone or any of that. Yeah.
Excellent presentation.
Thank you.
Congratulations.
Thank you
on
for
the
your help in the field.
Publication. You're welcome. Happy to help. Beautiful field site. Multiple part questions, so you can pick and choose to answer at least 2 of these. One, you mentioned that these changes happened within the last 75 years, but also that it was related to floods taking fish from the surface into the cave. So to what degree have you looked at the frequency of flooding events that take fish into the caves, and do they interbreed?
Right.
And then second, is similar in Mexico. Do you think that's the same thing? Was it first surface fish got flooded into the cave and they went deeper back in the cave, deeper than that they've been found at Honey Creek, into the dark zone? And then 3, let's see if I can remember the third.
I'm like a waiter remembering the table.
Well, here, answer the first 2 and then I'll ask.
Okay, so yeah, that's That's a great question. So, I mean, I make the strong case that these flood events occur frequently, and fish do get washed into the cave. And so that's got to be diluting what's going on with the cavefish population. However, explain the differences. Like, maybe it's just when you're raised at 72 degrees of perpetual darkness and low food, you get all these cave traits, which is great, because then I take it back to the Mexican cavefish people. I'm like, what are you really studying here? However, they've done all the laboratory breeding, right? All their work is with lab animals, and these are all consistent differences. But there's a lot of great questions there. And so if we find when we're raising these animals in captivity, by the way, all in the dark, all at constant temperature, do we see this difference between cave and surface morphologies become greater or lesser? So yeah, it's entirely possible they're kind of being slowed down in this process by these introductions. At the same time, it could be that, man, if you didn't get some more fish washing in there, they wouldn't make it. Like, you need some fresh meat in there to keep them going. The second one was, without a doubt, that's how it transpired in Mexico. We don't know because it happened so long ago. But you find, surface and cave forms in some of these sites in Mexico, and their surface forms are sort of living this long, miserable life, chasing a spot of light around the surface of a cave lake, where there's a skylight or something. And so you can imagine that these individuals, some of them do just fine in perpetual darkness, like the fish we pull out of wells. Some of those individuals may start to acquire these traits that become twilight, or then maybe straight up cave forms if you have master switches taking place. So yeah, I mean, without a doubt, it was a stepwise process. What's cool about Astyanax is that they're kind of predisposed to this. We have ample evidence from, even without studying the Honey Creek things like what we've done, that this species just likes it underground. They do a lot better. You find sunfish underground, they're miserable. You find, minnows and stone rollers underground, they're dying. Catfish do okay, right? They're nocturnal, but they're probably gonna starve. These guys, they're cool, they're chill with that. And we see it time and time again.
So part 3 of the question
Yeah.
was, can you speak to how this study relates to variation in surface and cave fern-baked salamanders?
Well, that's a tough nut to crack, but I think it's and I've been sort of cracking at that one for most of my career. I think it's exactly the same phenomenon. So, this is a great model system, and I'm really glad that I'm working with it, because we've got so many metrics we can use, like VAB and whatever else. They're like proven, approaches to analyzing these things. You start from scratch with salamanders, but when you find things that sort of live the same kind of life as the salamanders, including the salamanders that occur in Honey Creek, where you have surface, twilight, and cave forms at the same site, then yeah, I mean, I think it really helps us understand what's going on in that other group that has a similar life, evolutionary history.
Please forgive me if you've already mentioned this, but I'm curious on what the surface ratio to cave is on the breeding, and how many eggs they lay and how many actually.
We just collected animals for breeding this last year, so I could have that information for you soon. I don't know if it's going to be different or not. Good, but under the same feeding regimen and all that, it'd be really cool if we did see differences. So yeah, I'm completely willing to accept that this is all just environmental. That if you're raised in a cave, you've got certain differences. That's fine with me. To me, that's still really informative.
Yeah, you mentioned that the cave fish tended to be fatter.
Yeah, Mexican cavefish have tons more intermuscular fat than surface fish.
So I'm curious, the surface fish probably have more muscle because they're swimming around a lot more, and the cave fish are more sedentary. However, they're not having very much food on their buffet table, so
Right.
how do they get fat?
They have this crazy low metabolism and this ability to just coast through long periods of time without burning as much energy as a surface fish. And part of it is that there are these metabolic differences that have evolved in the cavefish populations. At the same time, remember, it's a short, violent life for fish on the surface.
So, are you saying it's gonna take 20,000 years to finish this study, or do you think they might have blind fish earlier than that?
I hope so. I said, I've found ways for the last 20 years to come up with excuses to go back to Honey Creek, but no, this is the first paper, but we're already working on a couple more. It's really fun, and I'm not interested in filling in all the pages from 0 to 20,000, but I think the first 100's really cool. It's kind of like a book that everyone studied in college, and no one ever had the first 100 pages, and we just found it. So it's really cool. Fun stuff. Yeah.
So when you're talking about the coral springs, is there enough genetic differences that you could actually tell when they pop back up in those springs if they came from surface or if they came from the cave?
We haven't done any of that level of genetics on them, and it'd be really tricky. For one, some of the reasons that Jessica mentioned, but still we're looking at all the fish in this part of Texas are less than 100 years old, and so you're probably not going to find genetic differences with those. One thing I did want to mention about cave versus spring, so for several of the assays that were done in the laboratory, you have to anesthetize the fish to do it, which means you chill the fish out. So if you throw the fish in ice water, it stuns them, they're paralyzed for a few minutes, and you can go about doing your studies. What Suzanne and her students found, which was really unfortunate for us because I had to go collect more fish, is that you take the surface fish and cold shock them and bring them right back up in literally 0 degrees Celsius water. The cave fish, you have to use water that's at least 7 degrees Celsius or they die instantly. So stenothermy, right? The organisms are adapted to a very narrow range of temperatures. We see a significant difference in thermal tolerance between the surface and the cavefish. So that's kind of cool. I'm thinking that's probably genetic. Yeah. It was really unfortunate, but then all those dead fish, we use them for other stuff. So
I imagine that makes it difficult to collect samples live. Having to remove them from their environment.
It's always challenging to collect things in caves. But yeah, the temperature thing's not hard. Go Yeti. Yetis are great. So I was telling, who was I telling her? I was telling Ron earlier that we're out at Phantom Cave in West Texas collecting fish and put them in small Yeti knockoff coolers and hustled them all the way back to San Antonio as quick as we could, but this was in summer. I shot the temperature on the water when we collected, it was 79 degrees. When I got to San Antonio and we're rushing to get all the fish out, it's 79 and a half. So that cooler technology is awesome for the work I do. Yeah. Thank you guys.